And we'll read the message again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, today we're going to wrap up the review. This will be our last official class meeting. I'll be back at 1:15 today for office hour. Your final exam, you can take it any time from now up until Monday. You have to be finished by 11:59 p.m. And keep in mind that once you open it and start it, the time begins. So you can't just do part of it today and part of it tomorrow, et cetera, et cetera. When everybody has finished taking their finals, which will be Monday night. So Tuesday, I will start. And as soon as I get all the grades calculated, I will email each person their grade in the class. I am on jury duty next week, so I don't know whether I'll have to go in. That'll affect when I have time to work on getting the grades calculated, but I will get to it as soon as I can. I would hope that I would certainly be done by like maybe Wednesday at the latest. Anyway, so there you go. What would you like to look at today?
Can we just go how we were going yesterday? I believe we left off on chapter 7.
Okay, let's see here. Chapter 7, we were looking at, that's right, I think we kind of finished it up. We did.
Yeah, I think we did.
Okay, so chapter 8. Is there anything in chapter 8 you want to look at? That was where we talked about functions. Let's see what else is in chapter 8. Yeah, we started with talking about functions, graphing functions, function notation. Anything particular you'd like to look at there?
Can you just do one of the problems, like a random one? Probably just
kind of to get your mind back into things.
Yeah.
Well, okay, here's an equation. It says h of x equals 3 divided by x minus 4. It says find h of 5 and h of negative 2. So h of 5 would be 3 over 5 minus 4, which is 3 over 1, or just 3. So h of 5 equals 3, which is the ordered pair 5, 3. Okay?
Okay.
H of negative 2 would be 3 over negative 2 minus 4, which is 3 over negative 6, or negative 1/2. So h of negative 2 equals negative 1/2, which is equivalent to the ordered pair negative 2 comma negative 1/2. You okay with that?
Yes.
All right. Let's see here. The function f of x equals 5 over x plus 1. What is the domain of this function? Well, we can't divide by 0. So if x plus 1 equals 0, we're in trouble. When would x plus 1 equal 0? Well, solving for x, we would get when x is negative 1. So that's the value that we want to exclude from the domain. So the domain would be everything from negative infinity up to, but not including negative 1, in union with everything after negative 1 up to infinity. So the domain of this function in interval notation would look like that, everything but negative 1, because f of negative 1 equals undefined. And we have to get a real output for the input to be in the domain. You all right with that?
Yes.
Okay, what about this one? H of x equals 3x plus 6. What's the domain of that function? Well, let's approach it this way. What's not in the domain? What value or values of x would not give us some real output?
Would it be 1 or 0?
Neither one. If you put 1 in there, you'd get 9. If you put 0 in there, you'd get 6. There's no denominator. There's no way we're going to be dividing by 0. So the domain,
All real numbers?
there you go. All right. While we're talking about domain, I'm going to jump ahead to chapter 9. And let's say we had this. We had g of x equals the square root of 3x plus 6. Now, how would you find the domain? Well, you can't divide by 0, but in chapter 9, we looked at the fact that you can't take an even root of a negative number. We're taking a square root here, so that means that 3x plus 6 can't be negative, so it has to either be positive or equal to 0. Okay, so solving that inequality, so greater than or equal to -6 divided by 3, x greater than or equal to -2. So here the domain would be from -2 to infinity. Okay, so we've looked at two major cases. You don't want to divide by 0, and you don't want to take an even root of a negative number. Okay, now let's go back to chapter. What? Yep. Okay.
Oh, sorry.
No.
If you were to divide by a negative, you'd swip the
Direction of the inequality sign.
Yeah.
Yes.
Okay.
Yes. Okay. Let's go back to chapter 8. Do you want to look at graphing functions at all? Graphing linear functions?
Yeah, can you do one of those, please?
Sure. Okay, let me switch screens. So we're going to look at this screen, and let's see here. Five, 5. Let's say we have f of x equals 2. Oh, no, it's doing that again. Doggone it. It was working fine earlier. Oh, well. F of x equals 2 thirds x. I discovered that if I go really slowly, it tends to work. But if I go too fast, it gets messy. Okay, so for this function, the slope is 2 thirds, and the y-intercept, I know this is painful, is -2. Okay, so we'll graph at -2 using the slope. We'll go up 2 over 3, up 2 over 3, up 2 over 3, and so then we can graph the line, and it's going to look like that. All right. Do you need any more examples of that?
No, that was good. Thank you.
Good, because I didn't want to have to write anymore. Oh, is it working now? Huh, now it's working. I don't know. Maybe it just took a while for it to catch up. Okay. So let's go back here to this screen. And all right. Write an equation for a linear function whose graph has the given characteristics. It has a slope of 5 and a y-intercept of -3. So that would be y equals 5x minus 3, or f of x equals 5x minus 3. Okay with that?
Yes.
All right. Write the equation for a linear function that has the following information. The slope is 1/4, and it passes through the point 8, 1. Now, 8, 1 is not b, it's not the y-intercept, but what we can do using y equals mx plus b, that goes in the place of m. Then we can take this ordered pair and put 8 in for x and 1 in for y, which will allow us to solve for b. So now we know the slope, we know the y-intercept, y equals 1/4 x minus 1. Using function notation, f of x equals 1/4 x minus 1. All right with that?
Yes.
Okay, can we go on?
Yes.
All right. Write the equation for a linear function that passes through, the following 2 points, -2, 2, and 2, -8. Well, I need the slope and I need the y-intercept. If I use the slope formula, I'll call this point 1 and this point 2. So y sub 2 is -8, y sub 1 is 2, x sub 2 is 2, and x sub 1 is -2. So we get -10 over 4, which is -5/2. So the slope is -5/2. All right with that?
Yes.
Okay, so y equals mx plus b. Y equals -5/2 x plus b. I can take either one of these points. I'm going to take the first one and put -2 in for x and 2 in for y. So I get 2 equals 5 plus b, because that would be 5. Subtract 5, b equals -3. So y equals -5/2 x minus 3 as a function. F of x equals -5/2 x minus 3. All right with that?
Yes.
Okay. We're going to come up with the equation of a linear function that passes through the point 3, 0, and it's parallel to the graph of g of x equals -2/3 x minus 4. Recall that parallel lines have the same slope. So since the slope of g of x is -2/3, the slope of the line we're looking for is also -2/3. So we're going to use this slope and this point. So y equals mx plus b. I put m in there already. X is 3, y is 0. 0 equals -2/3 times 3 plus b. 0 equals -2 plus b. 2 equals b. Y equals -2/3 x plus 2. F of x equals -2/3 x plus 2. And you're thinking, can he write any faster? Any questions on that?
No.
All right. Write the equation of a linear function that passes through the point 1, 2, and it's perpendicular to the graph of g of x equals -x/6 plus 1. Well, here the slope is -1/6, but since they're perpendicular, the slope we're looking for has to be the negative or opposite reciprocal, which would be plain old 6. So now I'm going to use this slope in this point. So y equals 6x plus b. 1 goes in for x, 2 goes in for y. 2 equals 6 plus b, subtract 6. -4 equals b. So y equals 6x minus 4. F of x equals 6x minus 4. So there's the equation that's perpendicular to that graph and passes through the point 1, 2. Let's see. Looked at, well, I'll see if I have any luck with this. I'm gonna risk and go back to the other screen, and we'll see what happens here. Let's say I've got this graph. Okay. Let's see, I'll move this in case it's covering the graph. Okay, so, and let's call this the graph of F. All right. So what would F of, let's see here, -1 equal? Do you remember how you do that? F of -1? So you'd look at the graph, you'd find out where x equals -1, which is going to be right here. What is the corresponding y value there?
2.
Okay. So f of -1 equals 2. What about, let's see, f of 6? What would that equal? This is 5 and 10, 5, 5.
It would be 2.
Yes, because it would be this point right here. Let me ask you this. What's the domain of this function?
All negative and positive real numbers.
So basically all real numbers. What's the range? What's the lowest y value on this graph?
-3.
What's the highest y value?
It'd be infinity, right?
Yep, here's your lowest value, and this is going to keep going up. So there's the range. You okay with that?
Yes.
All right. Let's see here. Absolute value equations. You want to look at those at all?
Yeah, we can look at one.
Okay. So if I've got the absolute value of 2x plus 7 equals 4, okay, then I'm going to get two possible outcomes. What's inside would have to equal 4 or the opposite of 4. Because if the inside equals 4, the absolute value would be 4. If the inside equals -4, the absolute value would still be 4. Does that make sense?
Yes.
All right.
Yeah.
So solving the first equation, we get x equals -3/2. Solving the second equation, we get x equals negative 11 halves. Let's check our work. Let's take x equals negative 3 halves. If we plug that in, we'll get 2 times negative 3 halves plus 7. Absolute value equals 4, which is negative 3 plus 7. Absolute value equals 4. Absolute value of 4 equals 4. 4 equals 4. It checks. Negative 11 halves, we'd get 2 times negative 11 halves plus 7. Absolute value equals 4. Negative 11 plus 7, absolute value equals 4. Negative 4, absolute value equals 4. 4 equals 4. So it checks. All right with that.
Yes.
Let's say we've got the absolute value of 3x minus 5 equals 0. So then you'd get 3x minus 5 equals 0, or 3x minus 5 equals the opposite of 0. But that's really just the same equation. So if you have an absolute value term set equal to 0, you're only going to have one equation to consider. Okay.
Right.
Oh, you said just do one. Do you want me to go on for something
No,
else?
no, this is perfectly fine.
Okay. All right. Sorry about that. All right. Let's say you've got an absolute value equal to a negative number. So then you'd have this, or that. So x would be negative 20. That's going to make it a positive 8. X would be negative 4. Well, if x is negative 20, we get the absolute value of negative 20 plus 12, plus 12 equals negative 8. The absolute value of negative 8 equals negative 8, but the absolute value of negative 8 is 8. That doesn't work. And if we put in negative 4, that doesn't work either. If an absolute value by itself is equal to a negative number, there's no solution. But I believe WebAssign wants you to go through, find the solutions, and then say that they're extraneous, that they don't work. Just read the directions carefully on that. Let's see. You might have something like this: 2 times the quantity x plus 4 minus 8 equals 14. You want to isolate that absolute value. So the first thing you would do is add the 8. Then you divide by 2. Then, once you've isolated that absolute value, you'd split it up into x plus 4 equals 11, or x plus 4 equals negative 11. Going on and solving it from there, x equals 7, x equals negative 15. Let's take the 7 and let's plug that in. We would get, let's see, 2 times the absolute value of 7 plus 4 minus 8 equals 14. 2 times the absolute value of 11 minus 8 is 14. 2 times 11 minus 8 is 14. 22 minus 8 is 14. 14 equals 14. So this one checks. Let's take x equals negative 15. And where am I going to write that? Let's see here. I'm going to erase this stuff so that I have some room to write. So we're going to have 2 times the absolute value of negative 15 plus 4 minus 8 equals 14. 2 times the absolute value of negative 11 minus 8 is 14. 2 times the absolute value of negative 11 is positive 11. Minus 8 is 14. 22 minus 8 is 14. 14 equals 14. And it checks. And finally, let's say you've got an equation with 2 absolute values. Okay. You want to have them separated. If you have one absolute value in an equation, isolate it, 2 of them, separate them. So now I've got 2x minus 4 equals 3x minus 5, or what's inside of one equals the opposite of what's inside of the other. So solving this first equation, I'm going to subtract 2x, negative 4 equals x minus 5, add 5, x equals 1. Over here, 2x minus 4 equals negative 3x plus 5. Don't forget you're distributing that negative sign through the whole thing. I'm going to add 3x. 5x minus 4 equals 5, add 4. 5x equals 9, divide by 5, x equals 9/5. So we've got those two solutions. Let's see, if x is 1, we'd have the absolute value of 2 times 1 minus 4 equals the absolute value of 3 times 1 minus 5. 2 times 1 is 2. 2 minus 4 is negative 2. The absolute value of negative 2 is 2. 3 times 1 is 3. 3 minus 5 is negative 2. The absolute value of negative 2 is 2. I just checked that one. You follow that okay?
Yeah.
Now
Yes.
let's do the 9 halves, and I'm going to need some room to write that. So let's see. We'll erase this stuff here so I've got a place to write it. 3 hours later, I've got this all erased. Okay. So we've got the absolute value of 2 times 9/5 minus 4 equals the absolute value of 3 times 9/5 minus 5. This is the absolute value of 18/5 minus, okay, I'm going to take 4 and change it into something over 5. So I'm going to multiply it by 5 over 5. So it's going to be minus 20/5. Are you okay with how I got there?
Yes.
Greg, you okay there?
Yeah.
Which is going to make this negative 2/5, which is going to make it 2/5. Here, I'm going to get 27/5 minus 25/5, which is 2/5. And there you go, the checks. All right. Okay, let's see. The other thing we did in chapter 8 was variation. Do you want me to do anything to do with variation?
Yes, please.
All righty. We had direct variation. Y equals k times x. We had inverse variation, y equals k over x, and we had joint variation, y equals kxw. Direct variation, as x increases, y increases. As x decreases, y decreases. Inverse variation, as x goes up, y goes down. As x goes down, y goes up. Joint variation, you have more than one variable on the right side of the equation. Let me write that a little bit more legibly. Okay, so there's your 3 types of variation. K is the variation constant. It's present in every formula. It's always on top. Sometimes it's mentioned, sometimes it's not mentioned. Often you have to figure it out as part of the process. Okay, so let's take a look at direct variation. Y equals kx. Here's an example. An object in free fall, so in other words, falling through the air, travels a distance s that varies directly to the square of time t. So s equals k t squared. S is the distance. It varies directly to the square of time t. K wasn't mentioned, but it's in there. If an object falls 1,024 feet in 8 seconds, so putting that in, this allows us to determine what k is. So isolating it, we get K equals, let's see, 1024 divided by 64 is 16. So now that we've determined what K is, that's going to go right up there. All right. How far will it fall in 10 seconds? Answer, 1,600 feet. One of the common mistakes I notice in variation is, let's say that in the original formula, a variable is squared. Make sure you keep that squared on the time, okay? Let's take a look at inverse variation. So y equals k divided by x. The frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. Okay, so the frequency of vibration varies inversely to the length of the pipe, where F is going to be the frequency and L is going to be the length. If a pipe 2 feet long vibrates 256 times, so the frequency of vibration 256 times the length 2 feet. So then to solve for K, we'll multiply by 2. So 512 equals K. That goes up here. How many times per second will a 6-foot pipe vibrate? And we get 85 1/3 times. Okay with that?
Yes.
All right. Let's see here. Joint variation. So something like y equals KWX or something like that. Okay. Oil storage. The number of gallons of oil that can be stored in a cylindrical tank, so we'll say number of gallons, G, varies jointly as the height of the tank, so that'll be H. Oh, K is also in there, and the square of the radius. So G equals KHR squared. And we've got this tank, and we're told that the height is 20 feet and the diameter is 15 feet. And they also tell us that K is 23.5. All right, so the number of gallons is going to be 23.5 times 20 times, what am I going to put in for R?
7.5.
Correct. When I do all the calculations, I get 26,437.5 gallons. Okay. We've got 16 minutes left. What do you want to look at? There's chapter 9, chapter 10, chapter 11. What do you want to look at? 9 is radicals, 10 was graphing parabolas and the quadratic formula, and 11 was exponential and logarithmic functions that we just tested over a day or two ago.
I think I'm good. I don't know if Greg had any questions.
Greg?
Yeah, I think I'm good too.
Okay, well, you can go, or we've still got 15 minutes if there's something else you want to look at. Up to you. You good? All righty. Well then, I will stop the recording and have a